Alright, let's begin with the basics. Measurements. When you're measuring length, the tool you choose depends on the size of what you're measuring. For everyday measurements up to a meter rule is perfect. But if you need to measure something longer, like the length of a room, you would go for a measuring tape. Now for really small objects, like the thickness of a wire, we use a micrometer screw gauge. This tool gives you extremely precise measurements, often in hundreds of a millimeter. Moving on to time. Measuring time accurately is very important in physics experiments. You might use a simple clock, but for precision, a digital timer or stopwatch is ideal. This is especially true for things like the timing for how long a pendulum swings. In physics, we standardize our measurements using SI units, the international system. We have meter for length, second for time, kilogram for mass, Kelvin for temperature, and ampere for electric current. These are your base units. You will see them everywhere. Now let's talk about quantities. Scalars are quantities that only have magnitude, like mass or speed. Vectors have both magnitude and direction, like force or velocity. If you're adding vectors, you use geometry, not simple math. You will often use the Pythagoras theorem and trigonometry to find the resultant vector, both its size and its direction. Next up, we have the measurements of volume and thickness. To measure the thickness of very thin things like paper, stack a bunch, measure the full height, and divide it by the number of sheets. You can measure volume using a measuring cylinder directly, or by calculation if it's a regular shape. The most important is the method used to find the volume of irregular solids. To measure the volume of an irregular solid, pour some water into the measuring cylinder and record its volume. Gently put a stone or the object into the water using a thread to avoid it splashing. Record the new volume level from the cylinder. The volume of the object is the difference between the two readings. Measuring the period of a pendulum requires multiple swings, since it would be inaccurate due to the human reaction error. Let's say 20. After recording your time, divide the total time by 20. Repeat it and take an average to reduce random errors. And always remember to reset your stopwatch before starting. This avoids the systematic errors. And speaking of errors, the two major types are systematic errors, which happen due to the faulty equipment or consistent mistakes, and parallax errors, which occurs when your eye isn't level with the scale.